friends, welcome to my channel. I'm in coaching center. So today I'm going to explain your 12th standard physics second physics 12th chapter, that is atoms part 2 video. So last video I explained you about Rutherford model and alpha tragedy I explained you about that alpha particle trajectory and some sums on the magnitude of force for magnitude of this force formula. This formula on you have to solve. They may ask you some sums in your final exam, I said. Next is electron orbit. So here also you have a formula. So here the distance of Fe between the revolving of electron. So the electronic force of attraction of Fe between the revolving of electron and the nucleus provided by the Fc to keep them in their orbits, thus for a dynamic stable orbit in a hydrogen atom. So we have to take that both formula, that is Fe is equal to Fe, and we have to write this formula, that is mv whole square by r 1 by 4 e square by r square, and then thus the relationship is between the orbit radius and the electronic velocity is r is equal to, we have to take e square by 4 0, or it may also say mv square, and the kinetic energy and electronic potential energy, that is u, electrostatic potential energy, you learnt in your electrostatic chapter, that is we call it as u, potential energy, electrostatic potential energy. So electrostatic potential energy we call it as u, so we will keep that k 1 by 2 mv2, this is the electrostatic potential energy formula. Next is e square 8 theta r and u e square 4 theta r is the next formula, and the negative sign of u signifies the electrostatic force, that is EKU, e square by 8 theta r e square 4 theta r, like that only e square 8 theta r we will get, and e square 8 theta r is the formula for this, and on this formula you have to solve the sums if they have given in your final exam. And one formula is e square 8 theta r is equal to 22 10 18j, and e square you have to put that 22 10 18j, and like that only you have to solve the problem. Next is atomic spectra. So atomic spectra, so it is each characteristic spectrum of radius which emits when an atom, gas or vapor is existed at low pressure. It is exists the atomic gas exists at low pressure, it is at very low pressure. So therefore the emitted radiation and spectrum which contains certain specific wavelength, the emitted has wavelength, and it consists of bright lines on a dark background. The spectrum emitted by atomic hydrogen is shown in 12.5 here. The first one is Lyman series, Balman series, Bastian series. This all you have learnt in your 11th standard. Your 11th standard you have learnt emission of ray in Lyman, Balmer series, Bastian series, and bracket series, and the P-Fund series you have learnt in your 11th standard, as you know. So next is spectral series. So spectral series, what here means, see here the Balman series in the emission spectrum of hydrogen. Now let's take an example of Balman. So hydrogen is the simplest atom, you know, it is a simple atom observed so first sight there does not seem to be any resembled of order regular in spectral line. There is in this line any resembled order is not, we cannot see, and John Jacobo Balmer is in the visible region of the hydrogen spectrum. So this series is called as Balmer hydrogen spectrum. It is called as this series here. This series it is called, and also to observe the wavelength r is equal to 1 by 2 2 whole power 2 1 by n power 2. So 1.097 10 to the power 7 1 by 2 1 by 2 power 2 1 by 3 power 2 m minus 1. So 1.522 into 10 to the power 6 meter minus 1 is the power we get, and that's why when we calculate it we get 656.3 millimeter is the thing we get when we calculate it. Next is like that only, that formula we will take as series. What we will do means r is equal to 1 by 2, so 1 r is equal to 1 by 1 power 2, 1 by n power 3 2, no. So what will do means here we will put 3 4 5. So what we will get means when we n means plus, no, so plus when we do 1 on the 1 5 on the 5, when we do plus we get 6 7 8, sometimes we get. So like this you should use. So rc is the, so Balmer formula is C is equal to VA is the frequency of light recalling that, or it we can say it as 1 by C becomes RC 1 by 2 power 2, 1 by n power 2 is the Balmer formula. So Bohr model of the hydrogen atom. So um, central nucleus and revolving electrons, proton and neutrons, like SN, as Rutherford said like that only. Bohr also said that. So while the planetary symbol in gravitation, the nucleus electron system, being charged objects, interact by Coulomb law of force. By Coulomb law of force, it interacts. We know that the object which moves in a circle is being constantly accelerated. You know, it will be accelerated. There will be speed in that circle. No. So the acceleration being centripetal in nature, according to classical electromagnetic theory. According to that theory, the accelerated charges particle they emits and radiation in the form of electromagnetic waves, electromagnetic waves, and the energy of declaring electron should therefore continuously decreases. The energy of electron continuously goes on decreases, and the electron would spiral inward or eventually fall into the nucleus. As the power goes down in the nucleus, it may fall to the, in the electrons may fall to the nucleus, because there is no power in them, because of the continuous speed of rotation, and their energy will be getting down by that. And also, as the electron falls, thus they would emit the continuous spectrum. They may emit as the electron forms, and so will be the frequency of the light emitted. As it falls, there will be continuous running only, no, but also the light forms in it. That electron in light forms, and that light spectrum, that light is observed clearly by the Rutherford model, tells us about the story of this. See here, in this Rutherford acceleration electron, it will be rotating. As it will be rotating, once it will fall. See here, proton, hydrogen, it will fall to the nucleus. Proton, hydrogen nucleus, to it the proton will fall down, or electron or new, or the charges will fall down, electrons will fall down, anything you can say, their elements, electrons, like that you can say. So this is the formula v by t, v by 2, or formula to solve here. Next is the Niels Bohr's formula is things, is postulates in this theorem, in this atoms theory, or the electromagnetic theory, you can say, or in Bohr's theory. What Bohr tell about the electron, let's know. Neil Bohr studied in Rutherford laboratory for several years. He studied, and also he concluded that in spite of success of electromagnetic theory, he also explained large-scale phenomena. It could not be applied to the process at the atomic scale. It could not be applied, and it became clear that a fairly radical departure from the established principle of classical mechanism and electromechanism would be needed to understand the structure of atom and the relationship of the atom. So Bohr combined the classical and early quantum concepts, and gave a theory in the form of three postulates. The three postulates he gave, they are: the first postulate is that he said that electron in an atom could revolve in certain stable orbit without the emission of radiant energy. He said that the electron will revolve in a certain atom without giving any more energy, radiant energy giving. According to their postulates, each atom has certain definite So according to his postulate, each atom has certain definite stable state in which they can exist. They have each stable state in which they can exist, and these are called as the stationary states of the atom itself. He named it. Next, his fourth second postulate is that the postulate states that the electron that revolve around the nucleus only in those orbits for which the angular momentum is same. The angular momentum is same is some integral multiple of h by 2x, where the h consists of Planck's constant, that is 6.6 × 10 to the power 34 Js, and thus the angular momentum L orbiting electron is quantized, and this is L is equal to nh by 2x. It became next. And the third law of Bohr is the third postulate incorporated into atomic theory, that the quantum concept had been developed by Planck and Einstein. The quantum concept that has been developed by Planck and Einstein, it states that electron might take a transition from one of its special non-radiant orbital. The electron may take the transition from other orbital, the same other orbital that has lower energy. When it does so, a photon is emitted having energy equal to the difference between the initial and final stage. There will be difference, and thus he gave the formula Hv is equal to E1 is equal to E1, and the angular momentum L is given by him is L is equal to mv, or where Ln is equal to mvn, or Rn is equal to nh by 2, where he gave this formula. And also n is called as the principal quantum number of the orbit, so Vn is equal to E by root 4 m or n. This is the formula. As you know, this is the formula where here it was given here in the Rutherford model. It was given the formula that only he had used that formula, and what he had, it means 1h by 2 he had added to it, and when we solved that, we got E is equal to 136.6 n square E by V. He got this when he solved that equation. So this is the formula he got, where the negative sign of the total energy electron moving in the orbit means that electron is bound with the nucleus. It tells us that electron is bound with nucleus. Energy will thus be required to that's the energy will be required to remove the electrons of hydrogen in that atom, in that radius. This is the formula that you have to use, the formula nh by 2 pi to solve the problem. So here you learn 3 problem, nh by 2 pi, and also you learn t square 8 t r, and also you learn 1 by 4 bracket 2e say t by t. This you learned. These are the formula here you learned in the starting 2 part of the chapter. So next part is here I will go to the second part, so I will explain the next part. So till then, watch my video, like the video, comment on my video, and subscribe my channel and coaching center for more video. I will explain the next part in my next video. Till then,